Good morning, everyone. So I'm very excited to present you our study, which is about a neonatal esophageal observation tube, a gastric feeding tube that has a monitoring function. So this is a pilot study that took place at the University Hospital in Basel. And inclusion criteria were preterm infants with a gestational age or a post-conceptional age of over 32 weeks that were in need of a gastric feeding tube. In these infants, we replaced a regular gastric tube with a Neo tube, that is a 6 French gastric tube, which is equipped with multiple electrodes. The tube was originally developed for the neurally adjusted ventilatory assist, shortly called NAVA. So on 5 days, we took measurements over this tube that was attached to an amplifier. Simultaneously, we catch the reference signal. For that, we attached 3 additional surface electrodes to the infant's torsus, and these electrodes were also attached to the amplifier. Also, we monitored the standard monitoring data of the NYCU. Then we visually analyzed our captured signals. By the visual analyzing, we had a customized software, and with this software, we chose of every hour of measurement 3 different categories of these signals. So we divided it in esophageal signals that were of very good quality, esophageal signals that were of not so good quality, and also the standard monitoring that was not of good quality. So moving on to the results. We were able to include 13 preterm infants with a mean gestational age of 33 weeks. We took 35 measurements that led to over 300 segments of these 10 minutes in each category that I was explaining before. That means that we were able to compare over 400,000 of heartbeats. So on this figure, you see now the signals that we captured. We have the esophageal signals, 8 for 8 electrodes. On the upper part, the most proximal electrode, on the under part, the most distal electrode. Then we have our reference signal, which was captured by these surface electrodes. And we have the standard monitoring data in the lower part, also with the numerics. On the first table now, we see the comparison of the heart rate extraction. We compared the esophageal leads with the standard monitoring. Our reference were these surface electrodes. So you see that in the nice esophageal signals, we have a very high sensitivity and also a very high positive predictive value. That means out of 1,000 heartbeats, we have only 3 heartbeats that were falsely detected. If we take a look at the poor quality segments of the esophageal and also the standard monitoring, we have a decreasing of the sensitivity and the positive predictive value, which is comparable. Now, on these figures, we see the deviation of these falsely detected heartbeats. So we have here the time, and we have here the amount. And we see that in the nicely signals of the esophagus, we have very few falsely detected heartbeats, and the most of them are in between of 1 second. So imagining a child who has a heartbeat of 150 per minute, this is not relevant for capturing a bradycardia or a relevant tachycardia. Also, we have on the not so good signals, more deviations, but also in the amount, if we have in mind that it is over 400,000 heartbeats, not so much deviations. So in conclusion, we could show that it is possible and it is also safe to extract a heart rate over a gastric feeding tube. And we could show that the results are comparable to the today's standard monitoring data. So if we look further into the future, we are now trying to do the same extraction with the respiratory rate. As you see on this side, we have a nicely respiratory signal in the more distal part of the electrodes. Also, we were able to extract swallowing acts. So here you see a peristalsis wave going through the esophagus, starting proximal, going more distal. So we are able to visualize a swallowing act. So if we imagine that we would be able to continuously monitor a swallowing breathing coordination, this kind of monitoring that we are looking at is really interesting. Thank you for your attention.
Thank you for this very interesting and enthusiastic presentation about a new tool. Is there any questions? Yes?
Is there a special technique to put this nasogastric tube in place? Do you need an X-ray to look at the position, or is it the same for a standard nasogastric tube?
Actually, we checked it by looking at the monitor. According to the electrodes, you can see the change in the R complexes, so you can verify the leading of the tube.
Thank you very much.
Is there any other question? No? No? So thank you. And